All right, we'll get started now because it's about one after. Hello, everybody. My name is Juan. I will be your moderator for this talk today. Today, we are happy to have Dr. Michael Morgan here joining us in our Tech Talk series to speak about emerging science and technology out there and scanning for the future. Before I pass it over to him to speak on that topic, I wanted to talk a little bit about AI futures first before we pass it over. So, going a bit into who we are, AI Futures is a program funded by the Department of Defense to essentially expose and educate students about various civilian jobs within the Department of Defense. Whether you are in a STEM field or your business, logistics, whatever it might be, there is an opportunity for you. And if that is something you're interested in, we do offer student services that allow some of our staff to sit down with you to work through your resume, work through your LinkedIn, and essentially get you ready for a position within the DoD. We have various partners such as the Navy, the Air Force, Marine Corps, various opportunities or various partners throughout the DoD to help transfer you over and get that job within the DoD. Going into the next thing, our events. As you see now, we're currently in one of our events, our technical talks, but we host various different events. We're at various different events. So outside of our technical talks, we do also do virtual panels. We've done some in the past where we have various subject matter experts come in and do essentially a Q&A session with you guys, whether it be asking about what a career looks like within the DoD, more technical fields like cybersecurity, things of that nature, whatever question you might have. We have subject matter experts here to answer those questions for you in those type of panels. We also sponsor hackathons for people who've heard of that, more STEM related. So for some of the programmers out there who've participated in those, we show up to those, set up booths, talk with students at those events. And we also have our own hosted events, our main one being the AI-GVC or AI Ground Vehicle Challenge. We have our own bots that we take to various universities, and we have a challenge that we take as well, where you essentially take these bots and get them up and running and moving throughout various courses. So various things that we do to help engage with the students and be that first contact with students to show that there's a lot of opportunities and there's various different technologies that you can work on if you do pursue your career within the Department of Defense. So that's about all I want to talk about right now. At the end of this talk, we'll be showing you ways to actually get involved with our student services. If you do wish to pursue a career within the DoD, or if you just want to say get your resume up or get your LinkedIn up, or fix your LinkedIn or fix your resume in any way. We do have people on staff to help you with that, but we'll talk more about that at the end of the talk. Right now, I want to pass it over to Dr. Michael Morgan to actually start the presentation. So feel free to take it away.
All right, thanks, Juan. Let's see here. All right, so thank you for inviting me to share with you some of the work that I've been doing in AI. I think, when you look across the federal government, there's a lot of work going on in AI. It's an exciting field. There's a lot of job opportunities. Having worked within the Department of Defense previously, super exciting, super innovative. The sky's the limit in terms of what you can do within the Department of Defense. So I encourage anybody who's interested in pursuing that opportunity to definitely try. I think it's a lot of exciting work. So hopefully some of this work will get you even more excited about AI. So I always like to start the conversation by just kind of like giving a simple definition. So what is technology? And it's really the application of scientific knowledge for achieving practical goals. So there is a lot of this play between science and technology is based on scientific application. What are foundational technologies? These are technologies that provide the underlying infrastructure that enable disruptive innovations down the road. Examples are like semiconductors, sensors, or networks. They lay the groundwork for breakthrough technologies like smartphones and Internet of Things. So think of them as the foundation, the building blocks to allow for the building of future technologies. Transformational technologies are a little bit different. They leverage the process of foundational technologies, and they radically reshape markets and industries, and fundamentally shift the way that business is done in daily life. Things like Internet of Things, cloud computing, they transform our interactions as human beings with devices or machines, data storage, and automated sensors across a variety of different industries. Disruptive technologies create new markets, and they do that by disrupting existing markets or displacing the earlier technology. The smartphone is probably one of the best modern day examples of disruptive technologies. It disrupted several markets to include digital cameras. Many people don't carry digital cameras anymore. Many of you do not carry music devices like iPods. Everybody listens to music off their phone. Video players, we all watch videos on our phone. We don't have satellite navigation devices like we previously had. Our phone locates us where we are and where we want to be. We read books on our devices, and we can record voices. And this list gets longer and longer and longer. And now we can use like ChatGPT and these other models like Anthropic, large language models on our devices as well. But this emerging technology is quite different in the sense where there's no real definitive definition of it. So the question becomes like, well, if there's no definition of it, how do you really identify it? And that's where kind of this story comes to fruition here. So as I mentioned, there's no real definition of it. The only thing that people agree upon is its high degree of uncertainty. They're really hard to predict. They lack any foundation in established knowledge, and the uncertainty tied to them is really unknown and very unpredictable. And so it mirrors the unpredictability of the future. So like, what would one of these hypothetical emerging technologies look like? Well, if artificial intelligence is today, when we see that going on, and we've heard about quantum computing as being kind of the next leap beyond artificial intelligence, well, what comes after quantum computing? Is it neuromorphic computing, which is mirroring the way that our minds work? So the processing of our minds, the way that our mind processes information, marrying that with computers. And so maybe that is one, maybe it's not. We don't know yet. But we can agree on, even though there's no definition we can agree on, there's certain attributes and characteristics that we can agree upon. They'll widely affect many sectors of the economy and society. They're generally on the 0 to 15 years timescale. So we're looking at what technology or science may impact us in the next 15 years. They're radically novel, they're fast growing, they have prominent impact. So if foundational technology provides the basis of infrastructure, and transformational technology brings about significant change, we're transforming, and disruptive technology revolutionizes industries, then emerging technology is really the forefront of innovation. And that's where we're really interested in trying to understand what technologies are really on the cutting edge, on the forefront of innovation. Here's a couple examples. A cryptocurrency came out, and Bitcoin was released in 2009. Since then, over 2,100 different cryptocurrencies have been created. 1 in 5 American adults have owned cryptocurrency, but the FBI says more than $10 billion was lost in fraud in 22 to crypto investment scams. Yet, more than 10 years later, the current president signed an executive order, which is the first ever whole of government approach to regulating cryptocurrency activities. So it took kind of the US government about greater than 10 years to respond to this novel technology where 20% of Americans are owning it, and $10 billion in fraud is occurring every year to scams. Drones technology. First drone was released in 2010 at the Consumer Electronics Show. This is a picture of it up here in the left-hand corner called the Parrot AR. In 2015, the FAA released a set of regulations. The Aviation Administration released a set of regulations that established basic rules for operating drones. In 2018, the FAA was caught off guard both for regulation infrastructure when commercial drone operators registered 175,000 registrations, which was almost a 200% increase from the previous year. And the individual who was responsible for this technology sector within the FAA basically said, like, please don't ask us to predict things. We're just really horrible at it. And I think, like, you never want to be in a position where, as a professional, you have to say those type of things. You always want to be able to say, we have a tool or a technology that allows us to predict things, and we're getting better and better at it. Of course, everybody has probably heard of, generative AI. GPT-1 was released in 2018 by OpenAI. 2023, they launched GPT 3.5, and now they're at GPT 4.0. They were the fastest growing consumer app in history, reaching over 100 million monthly active users. Hugging Face, when I made this slide, they were at 450,000 large language models. I think they're over 1 million now. And we got better in 2023, so like 5 years after GPT launched, now the government is starting to look into and doing a lot of work in that AI regulation, guidance, policy area. So, we're kind of getting better, but can we be better? Can we put those measures in place before we really need to respond quickly and reactively? Can we be more proactive? So we can no longer afford to be caught off guard. I love this quote by Stuart Brand. Once a new technology rolls over you, if you're not part of the steamroller, you're part of the road. Which part do you really want to be on? So there's a technique or framework that's been used for quite some time now in industry and academia, across the private sector, and in some early stages of the government. So it's called the technology foresight process, or the foresight framework. And the goal is really, it's a systematic exercise to look in the longer term future science, technology, and innovation in order to make better informed policy decisions. So if we can see things kind of bubbling up or emerging signals kind of start to show, can we apply this framework to kind of set in place effective measures to prepare for that emerging technology before it directly impacts society and the market? And it's really designed, again, to kind of foresee, shape, and direct change. It can be qualitative, it can be quantitative, or a combination of both. Here's the process, an overview of it. It's commonly broken down into 5 stages. The first one being establishing the domain, performing a current assessment of that domain, and then looking at the horizon to see what type of signals and trends we're seeing. The signals, trends, and sense making. So once we've identified the signals and the trends, can we make sense of those signals and trends? Establishing a baseline of future and alternative future scenarios. So looking at what's happening today and then thinking about what potentially could happen over the next 10 years. And then from those hypothetical or future scenarios, understanding what the implications of those scenarios coming to fruition are and what are the risks associated with them. And then backcasting to action, saying, okay, if those scenarios come to fruition and we recognize what the implications and risks of those scenarios are, can we backcast 10 years, from now and say, what measures do we need in order to put into place in order to thrive regulating or developing policy or developing guidance for a particular topic, emerging topic area. This is kind of a little bit more in-depth understanding of what that process entails. And kind of a little bit more understanding and granularity of what that process is. So you can actually do this foresight process or an iteration of it by basic web search. So you can kind of go through, Google or any other search engine, and you can ask it, what emerging science and technologies may impact society over the next 0 to 15 years. And if you do this enough and you ask enough specific questions, you can get some really interesting stuff from it. So here's an example, organoid intelligence, which is kind of this biological computing concept. It uses 3D cultures of human brain cells and then combines them with a computer interface and then wraps AI and machine learning around it. Cognitive security. Some of you may have seen Elon Musk's Neuralink, which is basically a brain computer interface, or a BCI. It connects to your mind, and the computer does things to help control certain aspects, maybe of your mobility, the way that your neurological response to stimulation. But when you combine a computer with your mind or your brain, then you have to think about things like cybersecurity. What happens if it becomes hacked? What happens if there's malware implemented? And so this is an area that you can identify as an emerging signal or emerging trend from basic web search. Lastly, many of you have probably heard of 3D printing. There's actually a concept called 4D printing. And then when you marry that with printing of foods, you get some pretty interesting ideas, or at least signals coming from it. The interesting thing from the 4D printed aspect is it allows for like sensory response. So like think about like something that you eat and then it dissolves in a certain way, or it makes your mouth respond by puckering, or it gives a heat or spice sensation. Imagine being able to emulate that by printing the fourth dimension in food. You can also use large language models to come up with emerging science and technologies as well. And so you can ask these large language models, can you identify some future emerging science and technologies that may impact society over the next, X given amount of time, whatever the time frame is. And it will come up with, different technologies. One example is metamaterial-based organ generations. Metamaterials are, for those who don't know, like designed to exhibit like extraordinary properties not found in naturally occurring materials. Think like, like Marvel Comics or something, when they make these, unique suits and capes and all these type of things. Like you could kind of almost envision them coming from metamaterials. But then when you kind of create metamaterials and you combine it with organ generation, can you create functional organs from a patient's own cells? So you take a patient's cells, you combine it in this metamaterial-based matrix, and then that combination allows you to grow your own liver if you have liver disease, or your own kidney if you have kidney disease. Quantum conscious interface, I think this is best described as, imagine me just looking at you and I'm communicating the information that I'm actually communicating to you right now without saying a word or making any movements or gestures. So it's just like my mind to your mind, and that's how information is communicated. And then holographic regenerative therapy, think about you're laying on a operating table, you've just had cardiac arrest, they're reconstructing your heart. They have like a 3D or 4D image already of your heart, and then they overlay that on your body through a hologram, or they overlay an image of a healthy heart over your body, and then they reconstruct your defective heart with the hologram of a safe and healthy heart, and they do that with holographic regenerative therapy. You can really go like a step further and say like, all right, well, let's just say that technology comes to fruition and we actually start looking at that technology, like what might we need to put in place in order for that technology to be properly regulated, for example, from a regulatory perspective. And the model will give you output from what it believes, effective regulation looks like, and that's here. Or something like what they call consensus standards. So consensus standards are essentially like a normalized way for everybody from all over the world to measure a certain thing. So like, even though you have like the metric system and the standard measuring systems, even though some people may measure from this part to this part and others may measure from this part to this part, a consensus standard is we're all measuring the same thing, we're all looking at the same units, and we're all doing it in the same way. So how would you develop consensus standards to measure certain impacts of that particular technology, or certain attributes or characteristics of that technology? And you can ask the model, and the model will provide you with this information. I'm going to go through an example of a specific, kind of topic that I've identified, and then walk you through this process of taking that topic and getting some meaningful information out of it, leveraging this foresight process and leveraging some of the AI. So you can kind of develop a solution, and you can kind of take different articles from across the web, and you can use this solution here in order to capture all of those articles. And that's kind of what they consider the scanning for the hits. There are different tools out there that you can use. Raindrop is another tool that allows you to do this. So you can either build something of your own, or you can kind of leverage off-the-shelf technologies. But what it does is it allows everybody from within your either university or within your team or within your organization to put a bunch of their ideas into this one location. And then as a team or as a group, you can identify, all right, out of all these ideas, this is the type of information that we want to explore a little bit more in detail. So what we do at that point is we bring a bunch of, once we kind of identify this topic area, this particular case, it's digital twins. So a digital twin is literally a digital representation of a object. Like, so for example, someone like a digital twin of a human being would be a digital twin of Mike Morgan. It would be a digital copy of Mike Morgan, or a digital copy of a Jawan. You could have a digital twin of a building. So it would be like an actual physical building, and the representation in a digital space, like a digital image, a computer image, a 3D or 4D print, 3D or 4D image of that, where you look at, water, the water pipes, the electrical, everything. It's an exact replica of a physical thing in a digital space. So we ask some subject matter experts, like, okay, so digital twins is going to be an area that we want to look at over the next 10 years. Can you tell us what you think is the social impact of digital twins in society, or the technological impact of digital twins in society, economic and the environmental and the political? And they put all these great ideas down on a piece of paper. And here's a great one. How would digital twins be handled upon death of a live twin? So let's say I have a digital twin. I unfortunately pass away. What happens with my digital twin? Does that continue to live on forever in a digital world? It's a good question. And so you kind of generate all these different unique questions from this process. And then you go to a process where basically you say, all right, we want you to complete this, these sentences. In a world where, and then you would say like, in a world where digital twins spread misinformation, okay, you say people will do what? Well, in a world where digital twins would spread misinformation, maybe digital twins, like the combination of them, would spread more and more and more disinformation. Maybe your digital twin, your digital twin would spread more information. And then, well, if that's the case, what needs to happen in order for this to be true? Well, large language models would need to be connected to our digital twin in order for that to happen, in order for that to start spreading mis and disinformation at a volume that, someone may be interested in spreading it out. So we'll take this information and this information, and then we'll ask the model, say, can you come up with some scenarios, some hypothetical scenarios that may happen in the future based on kind of some of the topics or ideas that we just discussed together as a group. And so it will actually do that. And so some of the interesting things that come from this are, imagine your digital twin can work 24 hours a day, 7 days a week, 365 days a year. Imagine if you had 100 digital twins doing that. How does that affect the job market? Does the job market shift? Or what happens if those who are suffering from a particular ailment or a disease, if there's 100 digital twins of them, can we administer different drugs at different administration regimens or protocols, and look to see which digital twin responds to best to which different administration or protocol? We can select that, and then that could be used as a basis for treating an individual. Remember, these are all hypothetical. These are all, speculative ideas. And then, so what happens, from an insurance perspective, right? Insurance and healthcare and the medical field, they're all intertwined and they're all, live in an ecosystem. And so how do you insure a digital twin? How do you insure a digital copy of yourself? What does that look like? What's the cost associated with that? Then you can look at implications and risk. And so so if these digital scenarios, if these hypothetical scenarios come to fruition over the next 10 years, then what are some of the implications or risks that could come from that? Well, in this particular digital twin scenario, you could have, if you create multiple self versions of yourself, does this erode the authenticity or trust or genuine human connection between people? Or what happens if I have a high income and I can afford to develop 100 digital twins? How does that change the disparity? Does it increase the disparity with those who may have a lower income and not able to afford to develop or build different digital twins? So what does that do to society? What disparity does that look like? And so here's another one. Will people just escape? Let's say there's they're experiencing a lot of anxiety or depression, or they're going through hard times in their life. Will they just escape their human life, their human form, and live in a digital world? These are some really interesting potential risks and implications. And so we then take that information, and then we look at this concept of, well, if those scenarios and implications and risks come to fruition, then what area, we ask the model, like if indeed this stuff comes to fruition, we ask the model, what things do we need to focus on over the next 10 years in order to get to a place where we thrive at living in this digital twin world? And then what strategies or measures do we need in what strategies or measures do we need to put into place in order to focus on what particular areas in order to get to that place that we thrive? And that is kind of like that whole concept of using the foresight method and leveraging AI to get to a point where you can kind of take a stepwise, practical, logical approach to looking at the future or looking in the future and grounding it based on kind of what's happened today and what has occurred in the past. So I'm going to show you just a couple other cool things. Remember, I said, well, if you do foresight, you can either do it quantitatively or qualitatively. So qualitatively, I just showed you what you can get out of that process. Well, quantitatively means that we're putting numbers to some of that process. So recall that I said you can gather this information in some sort of like software solution. I mentioned one called Raindrop. Imagine being able to take some of that information from the articles that you gather, and then you try to quantify that. In fact, we've done some early stuff in this area where we've kind of taken that information, we've asked the large language model to summarize it in unique ways. And then based on the output from the summary, we can then take that information and try to quantify some of that. And so what you're seeing here is what they call text mining. And I'm sure many of you have seen this word cloud analysis. This is like at the minimum, like the basics of, like natural language process or text analysis. And you can see here that, like, for example, the larger the word is, so the size of the word corresponds to the number of times that word has occurred within your corpus, your data set. So out of all that information that we mined, AI was kind of the largest. You can see some of the other things: quantum, language, intelligence, learning, data, computing, ChatGPT, COVID. So you can start to get an understanding of, like, not only the qualitative output, like these are the strategies that we're going to put into place, these are the areas that we're going to focus on, but now we can kind of start to back up some of that information with some simple data. You can go a little bit further. So I could take each article that I've found in my Horizon scanning. I can ask a tool to classify that, so it'll come up with a particular name for a certain topic area, like a unique name. And so, for example, this one here is ethical use of AI, and the one on the bottom is secrecy and safety of AI. Well, you can see that now the sentiment has some value here. So it's 100% positive sentiment, but the two that I just mentioned have negative sentiment. Sentiment means essentially, is people's perception of this particular automatic classifier, the title or the topic name that it's been given, is it positive, neutral, or negative? Okay. And so I'm interested in understanding where the negative sentiment is, because to me, that's where I want to be focused on. So this has 50% negative sentiment, and this one has 100% negative sentiment. So I can, what I refer to as like loosely correlate that negative sentiment to a SWOT analysis. So looking at the strengths, the weaknesses, the opportunities, and the threats of ethical use of AI and secrecy and safety of AI. And then I can ask the model again, okay, what are some of the weaknesses associated with ethical use of AI? What are some of the threats associated with the secrecy and safety of AI? And the model will generate that information as well. So now you can start to see we're now like getting into natural language processing, and we're getting quantifiable information. 100%, 29%, 5%, etc. Then you can go like a step further. This process is called principal component analysis, or it's commonly referred to as PCA. It's a pre-processing technique that's used for pre-processing your data for kind of machine learning. And you can take like the whole concept behind it is you take really complex data and you simplify it. And so we've taken like all of these like countless thousands and thousands and thousands of words, and we've said, can you give it some structure around these terms: AI, quantum computing, data security, research, and health. So this is what they call a cluster dendrogram. And you can see here that you're not really getting like, it's a little confusing. You're not really getting much information from it. Down here, the dendrogram is another way to portray this information. You can see it's like very noisy, like there's just so much noise in here. Each of these you can kind of see here, there's some numbers associated with that. Each of those numbers is associated with a unique article. But then if you look over here, the upper right-hand quadrant, you can see over here, the quantum and the computing on the right-hand side over by the, what is that, x-axis. That's where quantum and computing, the two terms, are found in the greatest number of incidents. And when you go to the lower right-hand quadrant, you can see that there's numbers associated with that. So the number 236, 345, and 1117. And so we can go into that article, those articles, and look to see where quantum and computing are closely, aligned with respect to one another. And so that's kind of a different way of looking at this particular data set. Now, I think it's like important to say, like, a lot of this is just purely research. We're trying to understand, like, what type of meaningful information we can get from these models, what type of applications we can use them for. And we use all of this information, like it's all freely available on the web. So, all the information we're grabbing is, from the model itself or from the web itself. So, yeah, that's kind of like, in a nutshell. It's 12:40. I know that we wanted to leave about 20 minutes for, question and answering. So I'm happy to answer any questions or try to do my best in answering any questions.
All right, let's get into Q&A. So I just want to say in advance, I'm sorry if I butcher anybody's name. First one here from Kajal Damar. What are some of the most significant AI projects or use cases that DoD is currently working on?
Good question. I don't currently work at the DoD. However, if you go to, I think it's ai.gov, there should be a resource for that highlights each of the use cases from each of the federal agencies or organizations. Okay, so you can go in and look at what are the use cases of AI for DoD. Okay, and if it's not there, then just Google US government AI use cases, and it should pop up there, and you can go and open up what each of the organizations, Department of Justice, Department of Homeland Security, DoD. Okay, great, perfect.
All right. Next question here from Hervey A. When using LLMs as an editor or brainstorming tool, how much input do you tend to use on the human side?
So a lot of this depends on, like, I always say, like, what you get out of a model is really dependent on what you type into it. So that, like, typing into it, that kind of construct or that practice is like loosely referred to as prompt engineering. Now there are, like, if you were to like be a prompt engineer, you would really understand like how the process works. You'd be able to explain all of this. You'd be able to understand like what, like one shot, no zero shot prompting is and all of this stuff. I am not a prompt engineer, but what I've done is spend a lot of time researching just through practice, like what prompts work best for like getting certain amounts of information or certain types of information out of models. So there are also like a number of like kind of what I consider like cheat sheets or guides or something that people post to LinkedIn all the time. There'll be like, or there's articles that like describe like the 10 best prompt techniques for use of ChatGPT. You can get some really interesting, meaningful information off of those, and then just go and start to utilize it, start to apply it. And a lot of it will come down to specifically what you're trying to get out of the model, and then like through trial and error, figuring out what type of prompts give you the best response for that.
Question here from Zane Klussman. Where do you see opportunities for an AI consulting business that helps small to medium-sized businesses that aren't currently utilizing AI? For example, a mom and pop shop down the street who aren't utilizing AI applications that can automate processes that optimize workflow.
I think like the sky is the limit, right? So like, I think if you understand, there's a lot of people that do not understand this, even the simplest concepts of AI. And just being able to help define or educate or inform people on those concepts is important. Of course, like when you start any business as an entrepreneur, the first thing that you should always be focused on is like, are you providing your potential customer or end user or client value? So like, what is your value proposition? So if you can go in there and say like, oh, here's an article that shows that when this person implemented this AI tool, they saved, 45% on human resource, budgets in an annual, per annual basis. Or when they use this AI email marketing tool, they generated, 250% more web traffic to their website, which resulted in 25% increase in sales. So I think there's a lot of opportunity. Understand what it is that customers or clients want, and then explain to them how your particular business or solution will provide them value. I think it would be my advice for that.
A lot of questions coming in right now. This one from Lauren Haley. What kind of qualifications or skills are needed for working with LLMs in this sort of manner for big organizations or agencies currently?
This is really interesting because I think like you don't need a degree in AI. You just need like real application skills. Like you need to be able to know how to use ChatGPT. You need to be able to understand how to use like some of the bigger, software applications. It depends on what you want to do. So like, if you want to get into AI, then there's things like I would learn I would learn the basic concepts of AI. I would learn how to use some of the large language models or large multimodal models, which means like Sora, which is like making video from text-based prompts. I would think about like trying to learn how to maybe like work with the models, like fine tune them. You could learn like some basic skills like Python. You could, it really depends on what you want to do. But I think the point being is that you do not need a degree. You don't even necessarily need a certificate. You just need the knowledge and the experience of actually doing it. And then you need to be able to effectively communicate that to potential client or customer. Now, again, as many of you are aware, you're all like, in education, in academia, like certificates are going to be an added value. A degree is going to be an added value, but do you necessarily need that at this point in time? No. You just need to be able to speak intelligently. You need to be able to like execute what you say you're going to be able to do for an organization. And if that's just you teaching yourself, then so be it, The sky's the limit.
Next question here from Jayanti Busal, if I'm pronouncing that correctly. Which is the most important sector of the DoD using this type of AI currently?
Again, I'm not a DoD individual, but I can tell you, like, just from what I've seen, they are using it in every aspect of the DoD, whether it's in like human resources or whether it's in like operations, like whether it's in like facilities and management, whether it's in like research and development, whether it's like in the field, like on the ground deployed. It's all over the place. There are so many, any mission space within the DoD, my guess is if it's not happening now in the very near future, will be infiltrated, and I use that term loosely with AI. It'll like AI will be integrated into that mission space at some level or degree moving forward.
Okay. This one might be a bit of a repeat question, but from Siddharth Mohan, what skills do you suggest for hardware engineers who are not really from AI software programming backgrounds to cope up with the tsunami of generative AI?
Yeah, there's some like, if you Google like top free Gen AI courses, if you're on LinkedIn, there's a number, like if you just put in the search bar like Gen AI courses and click on posts, there's a number of like courses that people like are using and are learning from. I'd suggest starting there. Like I think like Google has some free courses. Some of the big tech companies have some free courses. Start there. They'll give you everything from the introduction to like if you want to get into like fine tuning Llama 3, like they'll teach you how to do all that stuff too. So LinkedIn is a great resource for that. And, if you follow the right individuals there, like the AI kind of like influencers, then they'll provide you with a lot of the information that you would need in order to like figure out what type of training or hands-on application I would need in order to be successful in that space. So I'd start there, and I'd just start with Google. And then, again, at your leisure, like when you have an hour or two free, like during the week, like take a little course on AI, a boot camp on it, and start there.
All right. seeing a little bit of repeat, but there is one question here from Andre Johnson. Are you working with multiple acoustic hologram technologies?
Uh, so that particular technology that I identified is like a speculative technology. Um, you know, there are probably certain aspects of that technology that may currently be developed in like at some degree or some level within a technology, but I think that that particular technology, as I described it, has not come to fruition yet. To me, that's kind of a future technology that we may see in the future, but I would say at this point, I don't think it's there.
We have time for two more questions. So another one here from Hervey A. What are your thoughts on ethical AI?
Yeah, like super important question. You know, to me, I think like ethical AI, bias in AI, safety and security are like paramount. The ethical piece to me is really interesting. I think like you really want diverse, you want people from diverse backgrounds to be involved in developing AI. And the reason for that is that if you have like the same type of individual developing these models, then you're at risk of having like groupthink or bias introduced into that model development. But if you have people from all over the world with all different backgrounds, come from different, cultures, religions, classes, across different geographic regions, then all of that, all their thoughts and ideas and experiences and ways of thinking get integrated into the development of these tools and technologies. To me, that's really important. I think the ethical aspect, like we want, ideally as a society and as a people, we want to develop good, safe uses of AI. There will inherently be bad actors, and we can't control what they do, but we can put appropriate measures and frameworks and best practices in place to inhibit or limit like the unethical use of AI. And so that's what I think we should be focused on as we pursue this. And, I can tell you that while so many people are focused on building these new tools and getting them out to market and capitalizing off of them or profiting off of them, there's an opportunity for people to start really looking at like these areas like, transparency or ethics or bias or safety and security. And I think like that would be an area that I would be interested in looking at if I were somebody who was like maybe not super technical and didn't want to get into the coding and all of those aspects of it, but still wanted to have like a place at the table. You could talk about those things and you could explore and learn about those things. And then through that knowledge, be able to give advice based on your experiences and what you're seeing. So I think that's a great question.
All right. I think this is going to be the last question here because we're starting to run out of time. But last one from Caroline Deck. Do you have a list of people we could follow to find out more about the field or just a couple big players you would recommend?
Yeah, I'm gonna throw a couple names out there. There's one woman that I follow. I think she's great. Her name is Allie K. Miller, and you can find her on LinkedIn. There's another gentleman that I follow. Give me one sec here. Tell you his name. He's from IBM. His name is Armand Ruiz, Armandruiz. He's great. I started to come across this woman yesterday, Liyin, Liyin. She's got some really kind of interesting stuff. She's like a product builder. She just launched a company. Yeah, I think if you, Andrew Ng, he, ANDREWNG, Jan LeCun, YANNLECUN. I think if you follow those individuals, then start following them and then look to see who's commenting on and interacting with them. And then you can start to expand your network. But follow those folks. They're kind of like at the forefront, the cutting edge. And I think you'll find a lot of this stuff pretty interesting.
All right, then. Well, I want to thank you guys for all the questions that you brought to the table. I, again, also want to thank Dr. Morgan here for giving this great talk. Like mentioned at the beginning of the talk, we do offer student services here at AI Futures. So bringing that up really quick here, if you can, it should be up now on the screen. If you'd like to schedule a talk with us, we have 2 different QR codes here. One, if you want to schedule a talk Monday, Wednesday, or Friday at 5 p.m. Eastern. And we have another QR code here for Thursday at 11 p.m. Eastern, or 11 a.m. Eastern, I apologize. I'll leave this screen up for anybody that wants to scan that QR code. Again, thank you guys all for coming out for this talk. I hope you guys have a great rest of your week, and I hope to see you guys later.
Yeah, thanks. The sky's the limit, everybody. The world is your oyster. Go out there and take it. So thanks a lot. Good luck.
See you guys.